So in this lecture, we will discuss differentials and local linear approximation. So first of all, so so first of all, um, let us consider an example. Y equal to x square plus 1 is a function, right? Y equal to x square plus 1 is a function, and okay, so this is the graph of that function. It's in one variable. We will discuss first in one variable. So this is the graph of y equal to x square plus 1. Now if we take any point here, and if we take this portion and magnify this, we will get a straight line. Always there is a straight line approximately equal to a straight line. So we can approximate any value near this point by a straight line. Okay, so straight line is very easy. That's a linear equation, and we can easily find the value of that function at that point, nearer to that point. So if I take any point here, and at that point, near that point, nearer to that point, if we take a small portion, and if we magnify it, we will get a straight line. So any function, any differentiable function can be approximated by a straight line. And what is the best approximation? So what is that line? So what we will do is we will take the derivative or tangent line of f at that point x naught is the best approximation for f at that point. So we know that what is y equal to f of x is a function. Then we know that derivative f dash of x naught is equal to limit x tends to 0 or x tends to x naught f of or h tends to 0, that is best x plus h minus f of x naught f of x naught plus h divided by x. Now or or there is another definition for derivative, that is f dash of x naught is equal to limit x tends to x naught f of x naught minus f of x minus f of x naught divided by x minus x naught. Now what we will do is, we know that f dash of x naught is a real number. So if I want to find f of x minus f of x naught, f of x I'm not, this is approximately equal to this. If we So f of x minus f of x naught is equal to f dash of x naught into x, or approximately equal to x minus x naught. So f of x is any point nearer to x naught is approximately equal to f of x naught plus f dash of x naught into x minus x naught. So any value nearer to x naught can be any value nearer to x naught that can be approximated by a linear. This is a linear function. This is in some number f of x naught, and f dash of x naught is some number, and x minus x naught is one variable polynomial of degree 1, right? X minus x naught. So any function nearer or any function can be approximated by this. Okay. So in general, if we want to find any value nearer to x naught for a function f of x, suppose L of x be any value nearer to, then L of x, the value nearer to x naught, can be approximated by f of x naught plus f dash of x naught into delta x. What is delta x? Delta x is x minus x naught. Okay. Okay. So this is the idea. So any point, any value nearer to that point can be approximated by a straight line. So the best approximation is tangent line for a function in one variable. So now we are discussing function in two variables, right? So instead of derivative, we know that derivative of two variable, that means we always calculate f of delta f is change in f of, in one variable case, f of x minus f of x naught, right? So as in one variable case, the approximation f of x minus f of x naught, this is actually equal to, that is delta f is actually equal to, in one variable case, uh, but f dash of x naught into x minus x naught. So similarly, in two variable case, delta f is same as, delta f is approximately equal to fx at x naught y naught delta x plus fy x naught y naught delta y. So in two variable case, actually we have a surface. This is, if this is our function, instead of straight line, what we will do is, here if you have any point here, then if you take a small portion, that will be a plane, something like a plane. Okay, so that means if you take a small point and a small portion here, that will be approximately equal to a plane, and the best approximation of that plane is tangent plane. Okay, so that is the idea. So we will approximate values of uh, f of x, f of xy by using a plane, and that plane is called a tangent plane, and that is our idea. So we know that tangent plane is just derivative of total derivative of two variable. We know that derivative of, if z is a function of f of xy, dz is actually equal to fx x naught y naught into delta x plus, or dx plus fy x naught y naught dy, right? This is this what we studied in partial derivative. Derivative of z with respect to x is, with derivative of z is fx x naught y naught dx plus fy x naught y naught dy. This is called a total derivative. So what is delta f? Delta f is simply means f of x y minus f of x naught y naught. Okay. So we know that, actually we know that dz is the total derivative is fx x naught y naught dx plus fy x naught y naught dy. Now if it is in three variable f of x y z, then total derivative is dw equal to fx x naught y naught z naught dx plus fy x naught y naught z naught dy plus fz x naught y naught z naught dz. Okay, so this is derivative of in two variable and three variable. Now how we will use local linear approximation. In one variable case, we know that local linear approximation L of x is f of x naught plus del fx at x naught, that is derivative at x naught x minus x naught. So in two variable case, so we will write this is f of x naught plus delta x plus f of y naught plus delta y is approximately equal to f of x naught y naught plus fx x naught y naught delta x, fy x naught y naught delta y. So this therefore any value nearer to x naught and y naught, any value x nearer x and y nearer to x naught and y naught, that means uh, xy be some value nearer to x naught y naught, that can be approximated by using this formula. Okay, so so what we will do is, therefore the local linear approximation, that means value nearer to x naught y naught, that we can represent it by L of xy. L of xy equal to f of x naught y naught plus fx x naught y naught into x minus x naught plus fy x naught y naught into y minus y naught. So any value nearer to the point x naught y naught of a function f can be approximated using um, this value. L of xy is equal to fx naught y naught plus fx x naught y naught into x minus x naught plus fy x naught y naught into y minus y naught. And this L of xy is called a local linear approximation. Okay, this L of x naught y naught is called a local linear approximation. So what is local linear approximation? So simply I will explain what is local linear approximation. So if we want to find some value f of xy nearer to the, and we know that some value of the function x naught y naught at x naught y naught. So if we want to find value of f of xy nearer to some known value f of x naught y naught, then what we will do is we can find that by using a linear function. So this is a linear function, right? F of x naught y naught is a number, fx x naught y naught, that means derivative at point x naught y naught is again a number, and into x naught y x into x minus x naught plus fy x naught y naught into y minus y naught is a local linear approximation. So if we want find any value nearer to this point x and y, this is equal to, actually we already know what is the value at f of x naught y naught plus fx x naught y naught into x minus x naught plus fy x naught y naught into y minus y naught. So in this manner, so this is a linear function, right? So in this manner, we can find the value of xy, value of the function f of xy, and that is a linear function. So we will denote linear L of xy. So, and there might be some error, and we will calculate the error. So what is error? Error means, so there might be some error, right? So the actual value is f of xy, and our approximated value is L of xy. So this difference of this is error, and the percentage of error is this divided by distance from xy to x naught y naught. Okay, so that is the local linear approximation. So the problem is very simple. We will go to the problem. So let L of xy denote local linear approximation. Let L of xy denote local linear approximation to f of xy is equal to root of x square plus y square at the point 3, 4. Compare error in approximating this value by this value. So our function, given function is with the distance between the point 3, 4 and 3.04, 3 point, uh, okay. So this is the idea. Now what is the question? Question is, we want to find out a local linear approximation of the function f of xy is root of x square plus y square at point 34. Point 34. So point 34. Okay. Okay. So what is the idea? We know that local linear approximation L of xy is by using the formula f of x naught y naught plus fx x naught y naught into x minus x naught plus fy x naught y naught into y minus y naught. So this is the formula for finding local linear approximation. Okay. Okay. So that is the idea for finding local linear approximation. And we have given the values. Okay. So we have given x naught y naught, right? X naught y naught, x naught y naught is equal to, this is the given point 3, 4, right? And we want to compare the value of at f of 3.04, 3.98. So xy is 3.04 and 3.98. Okay. So first we will find fx xy, derivative of f at x and derivative of f at y. That means we want to find these two. Well, okay. So our function is f of xy is root of x square plus y square. If you find the derivative, derivative of this is 1 by, okay. So what is the derivative? Fx 1 by root of 2 into root of x square plus y square into derivative of with respect to x. So what we will get is x by root of x square plus y square. Okay. So that is the uh, fxxy. Now fyxy is equal to, if you find derivative with respect to y by root of x square plus y square. Now we will, if we find fx at 3, 4. So that means x naught y naught is, so what we want to find is L of 3.04, 3.98 is equal to f of 3, 4. X naught y naught is 3, 4 plus fx of 3, 4 into 3.04 minus 3 plus fy of 3, 4 into 3.98 minus 4, right? So first we will find fx34. So fx34 is, if I substitute instead of x3 and instead of y4, you will get 3 by root of 3 square plus 4 square, which is equal to 3 by 5. Okay, so this is fx6. Now fy34 is equal to 4 by 5. Now we can write what is local linear approximation. L of xy. X is Actually, what is x? X is 3.04 and y is 3.98. This is equal to f of 34. F of 34 is, so f of 34 is root of 3 square plus 4 square, which is equal to 5. So that is 5 plus fx34 fx34. This is equal to 3 by 5 into x minus x is actually 3.04, right? 3.04 minus 3 plus 4 by 5, y minus 4. Y is 3.98. So therefore, this value function f of 3.04, 3.98 is approximately equal to L of 3.04, 3.98 is equal to 5 plus 3 by 5 into 3.04 minus 3 is 0.04. Okay. Okay. And plus 4 by 5 into 3.98 minus 4 is minus 0.02. So the value is 5.008. Okay. So from the local linear approximation L of xy, by using the formula we get the value 5.008. So this value is 5.008. Now by using the calculator you can find the value of root of x square plus y square. That means instead of x, you can find 3.04 all square plus 3.08 all square. This is approximately equal to 5.00819. This you can use calculator. Now we will approximate the error. Error is difference between the actual value minus value we are calculated by using local linear approximation formula. So that error is this. Okay. Now, if you got the error, so error divided by the distance 0.0019 divided by distance. Distance is 3.04 minus 3 all square plus square root of 3.98 minus 4 all square. This is always is less than 1 by 200 times the distance, right? So you find out 0.0019 divided by this distance from 2 points, that is less than 1 by 200. So this is how we can find the local linear approximated value. So I will explain once more. What we will do is we will give a point 3, 4, and we have to find out the local linear value at 3.04 and 3.98. So we will use this formula of local linear approximation. So from here x naught y naught is given value 3, 4, and xy is the value we have to calculate 3.04, 3.98. Okay. Then we will use the formula and find the value. So if we get by using the formula we get the value 5.008. Then we can also use calculator to find the value, exact value. This is approximately equal to this. So these values are much closer. That means approximately they are equal. So we will find the error. Error is difference between the actual value and approximated value. So that error is this. And we want to compare it with the distance between these 2 points. What is distance between 2 points? 3, 4 and 3, 4 and 3.04 and 9. So distance, we know the formula, 3 minus 3.04 all square plus 4 minus 3.98 all square. So this distance we can calculate, that is 0.045, and we can compare. So this divided by this will be approximately equal to 1 by 200. Okay, so that is the idea. Now if we have a function of 3 variables, then what will be the formula for finding local linear approximation? L of x, y, z is equal to same. Here there is one more variable is here, there, z, f of x naught, y naught, z naught plus fx x naught, y naught, z naught into x minus x naught, fy x naught, y naught, z naught into y minus y naught, fz x naught, y naught, z naught into z minus z naught. You find this value, you will get local linear approximation. Okay, so this is the your homework. You just calculate these values, and I will send these questions in your WhatsApp group, and you just